excuse me, we are going to analyze or find the infinite limits analytically. That means no calculator. No calculator, okay? To, excuse me, to analyze x as x approaches 3 positive. Okay, 3 positive. Let me do one more thing here. Just a second, please. Whoops. Sorry. Okay. Do you still see my screen, my PowerPoint? Okay, I don't want to lose it. Okay, for this example, we are going to analyze it. For the function, as you see, if both a and b, we use the same function, 2 minus 5x divided by x minus 3, as x approaches 3 positive, and then in part b, as x approaches 3 negative. For the value x approaches 3 positive, that means x is slightly greater than 3, okay? And for part b, approaching 3 negative, that means x is slightly less than 3, very close to 3. We are not picking the number like 0 or 10 that far away from 3. We're going to look at the number very close to 3, for example, like 2.9999 or 3.001 or even 3.1. That would work because they are very close to particular number 3. And how do we analyze it? The sensitive one is the denominator. We're going to start with the denominator. If you pick the number as x greater than 3, for example, 3.01, okay, 3.01 subtracted by 3, what would be the sign of the result? We know it's positive, right? Because x is slightly greater than 3. The sign going to be plus sign, but the quantity is very, very small. Why we know it's small? Because we take the limit as x approaches 3 from the right side. At the right side, x is greater than 3. Any number greater than 3 will give you positive for the result. And the quantity going to be small. We don't care what that quantity is, but we're going to analyze it by using the term either small or large. In this case, going to be small, but the sign is more important, whether it's positive sign or negative sign. So we know that denominator going to be very small quantity, but in positive or positive inside. And now the numerator is not the troublemaker or not the one that we have to worry about. We just replace it with the value 3 because it doesn't matter the value 3.01 or any number lower than 3, because when we plug in, it's going to approach to that function value. Think about when you find the limit of the polynomial, it's the same as to plug in to find the function value. So we're going to replace the top number, the function, the numerator by the value 3, which will give us like 2 minus 5 times 3, or like 2 minus 15, right? 2 minus 15, that gives you negative 13 on the top, divided by positive, small, very, very small quantity. And think about when you divide negative sign by positive sign, the quotient will return negative inside, correct? It will be negative inside as the final result. And 13 is the real number divided by very small quantity. Think about any real number divided by very, very small number. The quotient will get larger and larger as the number at the denominator gets smaller, correct? And the notation that we use to represent the very large amount would be infinity. Okay, therefore, we know the limit of this function as x approaches 3 positive will approach negative infinity in a graphical way. At 3 here, we know it's going to be a vertical asymptote. As x approaches 3 positive, the graph approaching negative infinity. Questions? No, or don't know what to ask. Yes. So let's see the next one, and you can compare from the left side, from the right side. Okay. All right. In part B, x approaches 3 negative. For x approaches 3 negative, that means x is slightly less than 3. Okay. The troublemaker is the denominator. We don't want the denominator to be 0. So we assume the value that we enter in here is very close to the 3 from the left. For example, 2.9999, or number slightly less than 3. If we pick 2.9999 minus 3, we're going to have negative as a result, and the quantity going to be very, very small. And what I said earlier for the numerator, there is no problem. You put lower than 3 or greater than 3, as long as that quantity is very close to 3, you can treat it as the normal function evaluation. So you get negative 13 as part A and divided by negative small quantity. Negative divided by negative give you positive sign. Any real number divided by very small quantity give you very large amount, or the infinity. So for case B, at the point 3, we get the vertical asymptote. The graph of the function as x approaches 3 from the left, approaching positive infinity. Okay? So then both sides will give you a different one. So I'm gonna put in the calculator and we'll show you. Or you can check with your calculator as well. Make sure you adjust the screen, the windows, to see, to include the x equals 3 in your window area. Okay, so 2 minus 5x divided by x minus 3. Then I will switch the screen and show you what's going on. I switch the screen real quick and you see the graph. Okay, you see the graph. I usually use desmos.com as the quick or the handy web-based calculator or graphing calculator. So I put in the function 2 minus 5x over x minus 3, and you see the red curve represents the graph of the 2 minus 5x over x minus 3, or the function f of x. And then the line, the vertical line, x equals 3 as a vertical asymptote. On the left side, as x approaches 3 negative, the graph approaching positive infinity. And as x approaches 3 negative or positive, the graph approaching negative infinity. So we could do it by hand. So this way it's called like find the limit analytically and then check with the graph to compare the result. Okay, and I'm gonna get back to the problem. All right, so you guys okay so far? Have questions? Anything that I can add in before we move on to the next one? All good for now? Okay, all right. So I'm gonna skip C and D and then go to, let's see, this is 2 minus 2 plus. Okay, I should put in the same one. And then, all right, I'm gonna skip the C and D. We'll work on the E, and then I let you work on the C and D after that, okay? Just the same way we analyze this limit, just basically do it by hand, not using the calculator. This one looks a little bit more complicated than the first two examples that we just did, or what I just did to show you. The expression x minus 4 divided by x times x plus 2 quantity squared. This one, as you see, let me see, 1, 2, okay. Approaches -2. Superscript negative sign, that means x is less than -2. Okay, if you think about the real number line to help you out, -2 right here. So you pick any number on the left side of -2. Okay, for example, x is -2.1 or -2.01, as long as the number on the left side of -2. Now we analyze it again. As we can work on the numerator to get it out of the way. Since the numerator has no problem as you substitute or replace x with the value -2, it doesn't matter the left hand side, the right hand side. So we put -2 here, minus 4. We know that the numerator gonna give us -6, okay? But the trouble is on the bottom of the denominator. We look at one at a time. For the x itself, the sign will be negative with the condition that x approaches -2 on the left. Anything below -2, the sign is negative because x -2 is already negative sign. Anything lower, still negative inside. So x term gonna be negative inside. Okay, and for the term x plus 2, x plus 2 itself. That means whatever the number that you pick on the left side of -2, you add it by 2. Let's say you pick x equals -2.01. And then you add that number by 2. If you add 2 on top of it, you're going to get negative inside, right? You're going to get negative, but very small, very small. But you are not just using the x plus 2. You are using x plus 2 squared. So the sign of this is going to be the sign of negative and very small number squared, which means you multiply negative sign twice. So the result of the power 2 term going to be positive inside, and the quantity still remains small. Okay, so the way we analyze, that means this factor, the x going to give you a negative sign. The square of the x plus 2 going to give you plus sign and very, very small. And then we get -6 divided by the bottom. The overall sign going to be negative with very small quantity. In general, you're going to have positive sign for the quotient because -6 divided by negative quantity on the bottom, and the top number divided by very small number on the bottom. That means the quotient gets larger and larger. So the limit of this function approaches positive infinity as x approaches -2 from the left side. So x equals -2 is the vertical asymptote. On the left side, the graph approaches positive infinity.